We'll be starting in 1 minute. Still, I'm seeing a few people are joining, so I'll wait for one more minute. Okay, so let's get started. One second. A few people are joining. Okay, cool. So today we are going to study design of a chat system, and let us try to firstly see the requirement that we have for today, and then we will start discussing on the design. So this requirement this time is quite simple. So we are going to design a chat system very similar to something like WhatsApp. Okay. So that will be our reference point. Just a minute. 1 second, guys. One second, guys. There's some issue in my sharing. Just give me a moment. Okay. Okay. Is my screen visible to everyone properly?
Yes.
Okay. Thank you. Thank you. Okay. Cool. So we are going to design a chat system, and we are going to design something very similar to WhatsApp. So this is a question that has been given to you, let's say in a system design interview, and we will approach this question again in an interview format. There will be places where I'll halt and explain concepts, but mostly the agenda is going to be very similar to interview format. We will be leveraging some things that we have studied previously, like design a notification system, rate limiter, and whatnot. So we will cover all of those aspects today. Okay. So let's get started. So you have been given this question in an interview, and of course, the first thing that we have to do is ask some follow-up questions so that you understand what the interviewer actually wants. Because if somebody asks you to design a WhatsApp, it is a highly ambiguous question. What feature of WhatsApp should you focus on? Because WhatsApp also has profile creation, authentication, authorization, and a lot of other things. So what is exactly that you want to focus on? So you need to ask some clarifying questions to the interviewer. So firstly, you will ask the interviewer that what is the functionality mostly that the interviewer is interested in. Okay. Okay. What functionality? So answer mostly in this case will be that design it for chatting. Okay. Now this is also a quite this is also not a very pinpointed answer. So again, you need to clarify that what kind of chatting, right? Kind of chatting. How many types of chatting are there? Two types, right? Whether it is one-on-one or group. Okay. So let's say interviewer says design for both. Okay. What? One second. Okay. So let's say we want to design for both. Okay. Now, let's say somebody asks that what is the scale? Then you next question that you'll ask, what is the scale for this? So scale, let's say you need to figure out the other details, but let's say the interviewer only tells you that there are 50 million monthly, sorry, not monthly, let's say daily active users. Okay, these numbers are very relevant to WhatsApp numbers. So keep noting all of these question and answer. Again, because group chatting is supported, now you will know later in the interview why this question is important, but you should definitely ask, what is there a limit on group member size? Okay. Generally, you will see that all chatting platforms have a group size limit, generally 100. Okay, let's keep it at 100, and we will know why this limit is there. So, and any other question that you can think of? One more question, technical question that somebody can think of, like what can be message size, right? And what type of messages are supported? Message size and type. So let's say we firstly solve it for text messages and size, let's say 100,000 characters per message. Okay, doesn't mean that entire WhatsApp will have 100,000. Like one message can have 1 lakh characters. And first we will solve it for text messages. We will see how we can take it forward for other type of messages like video, audio, and images. So these are the requirements that we have. Now, not requirements, these are the question and answer that you have done. With this, you need to create, now you need to come up with a requirement. Okay. So now you have to tell what requirement you want to conclude from this. So let us write that. Yes.
One question.
Any questions?
Yeah. So we have mentioned 50 million, right? But in that, those are active users. So should we consider something like how many people in that active users, how many average they are sending messages, how many messages? So
we
such
have to do that. We have to do that. Right now, we haven't come there till yet. So this is a question. Basically, you are right now clarifying the question. Okay. Like if we are designing WhatsApp, so you have asked the interviewer these questions. Now with this, you have to come up with your requirements. I'm still coming to that. And then you need to estimate also. But what are you estimating? Why only chat? Why not authentication? If there are 50 million daily active users, with this, what data do you want to estimate? Why are you only looking at chatting number, right? Because you have asked the interviewer that you have to focus on chatting. So basically right now you have just questioned the interviewer with what is he wanting you to design, and now whatever data that has come with that, you are going to finalize the list of requirements, then try to estimate. So this is the format, right? Estimation will come later. You are right, we will do that. We are yet to do that. Okay. So far, any more questions you may want to ask an interviewer? If let's say somebody has asked you to design a chat system like WhatsApp, yes. Any other questions that you would be interested in?
Latency or
Good. Good question. So if you ask latency, what should be the answer here?
real time.
Real time. Okay.
And how many days data should be stored? Such information.
Yes. Storage. Now, answer here can vary. Now, somebody can say that you can store entire chat history. So now here you need to, this will be your call basically. You need to decide how you want to store. Do you want to store the data, all the chat history, 3 years, 5 years? So here answer will be, we want to store as much as possible. Whatever you seem is relevant, right? We would like to store that much. Any other question?
Do you want to enable calling feature? Calling feature.
Calling feature not supported. This is the chat system currently.
Okay.
Offline, should it work? So such.
No.
If it is like even if internet is not there, the person should be able to browse the messages. So that can change the design.
That is expected. You can browse your messages if you are offline. How will that change your design? Browsing can happen, right? Even if you are not connected to internet.
Ability to log in from multiple devices at the same time.
Ability to log into multiple devices, okay. Multi-device support. So in a WhatsApp-like system, answer is going to be no. Okay, but if this is a messenger, Facebook Messenger, then we would have gone with a yes. And they differ quite a lot. So right now, let's say multi-device support is not there. Okay, so if somebody has given you that you want to design a system like WhatsApp, so there are some questions which you know the answer, right? So those questions you don't ask. Like latency, we know is real time. This is not a good question. Storage is a good question, right? How much do you want to store? What should be the strategy? Multi-device support we know is not supported. WhatsApp is supported only on one device, right? So if the question has been given to you,
now on multiple devices.
sorry,
It is now supported on multiple devices.
what WhatsApp?
Yes.
Maybe, I'm not sure. I'll take your word currently, but I'm not sure. I think WhatsApp for business is supported on multiple devices.
I use personal WhatsApp as well on multiple devices. On PC, on different PCs and phone.
On acha, in that way you want. Yeah, so you can. Okay, so basically, I think multi-device support, if you are talking with respect to that, can you support it WhatsApp web on laptop, mobile? In that case, answer can be yes. But I don't know how that will be relevant in the design. But yes, let's say you support it on multiple devices as well. Same account.
What about encryption? Like
Yeah, encryption is a
message
good
encryption.
question. Should encryption be there? So answer right now, let's say, is that good to support. Okay. It's good to support encryption. Again, one more thing. Okay.
How
Any
about
other
for
questions?
export? We can export the chat also.
Mhm. Yeah, we will keep that. That's not a very
And-
relevant, in my opinion.
And
currently.
that double tick, blue tick, all those things. Do we
Good.
want the
That's a
notification?
good point. Yes. Message status, right? That's a good feature to have.
Yeah, we should also support like media files, like not only text.
I already answered that. We are
Uh,
going to support text, and we can extend it if time is there. Again,
file
okay,
status?
so that's okay. We can stop here on requirements. So
User
again,
information, what kind of user information are you storing?
we'll discuss that. Okay, so one more thing. Please be on mute for now. It's okay. I understood there are a lot of questions. Let me set the context first. So we are going to study design a chat system. And initially, this is the interview format, right? So WhatsApp has hundreds of functionality. You can't design everything in an interview. That's why I came up with a finite set of questions that this session will be focused on chatting part, which includes group chatting, one-on-one chatting. So that will be the focus area. Of course, you can't design WhatsApp in 2 hours. I hope we are all sensible that this is not possible to design WhatsApp in 2 hours in any interview. So the point that is trying to be conveyed here is that you need to discuss with the interviewer what features you need to focus. Okay. So for example, encryption in itself will be a good problem to solve. That how do you encrypt messages? How do you store messages? How can you guarantee privacy, etc. If I start combining with this one-on-one chat, group chat, everything, then time can be short. So first thing that you need to know in a system design interview, that you need to pinpoint which feature you want to design. If you ask these questions to an interviewer, let's say he says yes to all of them. So what do you do then? Let's say he says yes to all of them. So will it add as a good point in your candidature in that interview, or will it cause problem in designing the feature, right? Because now you have multiple things to focus on. So here, the tip is that you need to focus on one specific problem. Your whole mind, you want to focus on one specific area of problem or 2-3 areas of problem only. So for example, I started with chatting. Then we are dealing with the scale. We are dealing with group chatting. We are dealing with text messages. Okay, so we have limited our scope. If I start including images, videos, everything together, it will be impossible to design such a system, right? So firstly, limit your requirements. Of course, some context of WhatsApp is anyways there with you, because WhatsApp is something that we all are using. So those questions are not necessary to ask whether images are supported or not. Yes, they should be supported. You can go ahead and design for text, but keep your design open that tomorrow images and media can support it. These are so questions that you ask during an interview should be relevant to the design that you're trying to make. Okay. So with these set of questions that we have, we need to finalize a finite set of requirements on which we can create our design. Okay. So the next step here is that we will write some finite set of requirements that we have come up with all these discussions that we had. So the top MVP requirement is one-on-one and group chat support. That's the top requirement, and that's the top feature of WhatsApp, which an interviewer is interested in while he has given. For example, let's say WhatsApp is solving multi-device support. That's not a unique problem that WhatsApp is solving, right? What is the unique problem that WhatsApp is solving? Chat support. Another thing which was brought up in discussion, message status. What are message statuses available today in WhatsApp? Firstly, you write a message. So you can call it at created. Then after a message is created, it is accepted by WhatsApp, like it has been sent from your side. Okay. So you can call it as received by WhatsApp. Then next status of a message is, once it has been received by WhatsApp, has it been delivered to the user, right? To the person whom you are trying to send. That is sent. And then once he reads it, it is called as read. Okay. So icons, basically here, this icon comes when it is created. Single tick comes when it is being received by WhatsApp. Double tick comes when it has been sent. And blue tick comes when it has been read. Okay. So this is a very important feature which WhatsApp is offering. What are other features which WhatsApp is offering? Next feature is push notification. WhatsApp notifies you of messages. It's not like you open WhatsApp and only then you get to see all the messages that is there on WhatsApp. You are notified of or any message if WhatsApp is not opened via push notification. So that becomes a very important feature here. What are other features? Let's go back to our question and answers and see. So chatting is done. Group chatting is done. Scale, we will come to it. Group size limit is there, that you have been answered. Message size limit is there. Multi-device support, we will handle that as optional requirement. Latency is there, again, soft requirement. And encryption. Okay, so now we will add encryption. And then in non-functional requirements, so there are two types of requirements. Functional requirement is functionality wise requirement, and non-functional requirements are performance related. So latency has to be very low. So here I will write real time. Availability has to be high. WhatsApp or any chat system should always be available. Scale, we need to estimate. We know that scale is 50 million daily active users. Okay, so with these finite set of requirements, you are set for the next 1 hour of discussion that you are going to have with the interviewer. Okay, so you are set for the next 1 hour that these are the focus areas that you will design. Okay, so this has to be done before you start designing or proposing any design. Because let's say if somebody asked to design WhatsApp, but the main feature that he's looking for in WhatsApp is how WhatsApp stores messages. It does not store it with itself, does encryption, and rather allows clients to choose that functionality. So that design deep dive can be a 1 hour discussion of its own. Group chatting can be a 1 hour discussion of its own. So deciphering this is also it is very, very integral part of a system design interview, because in system design interview, we don't only check your technical knowledge, but we also see how you collaborate with others and how do you drive clarity, because these are things that you will do at your job also. So now with these requirements, let us start proposing some high level design, and let us see how we can design the system for chatting. Okay. So firstly, we will focus on the MVPs. So the MVP, as we all know here, is these two features. If you are done with these two features, then half battle is won. Next few things we can solve easily. For example, push notification, we already know how to solve. We covered it in a previous class. Encryption is not a very new problem that WhatsApp has solved. It is a solved problem. How you integrate it is something we can do it. So again, that will not be a very hard thing to impose. So these two things are MVP, and in these two things, latency comes because both the group chatting and one-on-one chatting have to be real time. So moving forward, now let us try to see that how WhatsApp can be designed. So let us start with basics. Okay. So there is two users, A and user B, and let's say not a system. Let's say you have your entire WhatsApp as a service. Okay. So let's say this is your whole WhatsApp ecosystem. So A sends a message and B receives a message. Firstly, we will discuss on one-on-one chatting. Okay. Then we will see how this can, or we need a new design for group chatting. So A sends a message to B, right? So basically on WhatsApp, you will open your chat window, find the person B, type some message and send him. And once you send the message, then something like this, a function call will be made with the message and the person you want to send the message. Okay, recipient. And then this is received by WhatsApp. And something happens here. And WhatsApp routes this message to B and sends this message to B. This message is received by B. What happens in the middle is what we need to decide. So let us see what problems can be there. Let us start with the most basic design, that we replace this WhatsApp whole system with just one server. And let's see if this is possible or not. So let's say that there is one server. Let's call it chat server. In which, let's say A sent a message to this chat server. Let's say message is hello. And he has sent it to B. So firstly, chat server needs to figure out some basic information about B. These are trivial things. For example, WhatsApp, when A sends a message to B, then how is B denoted in WhatsApp system? You need to decide that. So let's say you are sending user IDs. Okay. You have sent the ID of B. And now from the ID of B, chat server has to figure out how to reach B, right? B is connected on his mobile device. On what IP address is he sitting at? What location he is sitting at? Is he even online or not? How will this chat server know, right? Because what is a trivial messaging system or a trivial communication with a client to chat? Trivial client server system is that a client requests something, so he sends a HTTP message with his IP address, and server receives the message along with IP address of the client and responds back to the IP address. This is a very simple system. But now A is sending message to B's ID, which is the ID with that WhatsApp honors. Now chat server doesn't know what is the current IP address of B. So how will chat server send the message to B? Now this is the problem on which you need, and this is the main system design problem that we need to solve in WhatsApp. Okay. So we start the design at this point. There are two problems here. Problem one, how to find B. And I hope you understand what do I mean by find. How to find that where do I send this message? What is the IP address at which B is sitting? What type of device B is having? We don't know anything. And two, can a server send message to B without B requesting it? How to send a reply without request? Server send reply for a request. here B has not requested anything, but B will receive a notification from WhatsApp in real time. Okay. So there are many ways to solve it. So let's discuss on point number 2. So in point number 2, let's say you received a notification from Hotstar, Netflix, whatever. So there what happens is, these are not necessarily to be real time, right? So your client application that you install in your mobile phone, let's say for YouTube. Okay? For YouTube, you all have a client application that you have installed. That client application in the mobile keeps requesting the server, is there any new content for this person? Is there any new content for this person? And the server will say no, 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 no. Like let's say every 5 minutes it keeps requesting. And whenever a content comes, server sends the content and it comes as a push notification in your mobile. This is how generally notifications work. But how is WhatsApp different here? WhatsApp is a real-time chatting system. So the notification has to be real-time. Even 5 minute lag. Example, let's say I'm chatting with you and your messages are coming to me 5 minutes later. Can we have a good chat? No, not possible, right? So here we need to crack that how is the server sending messages to a client which has not requested anything to him, and how can A and B chat in real time? So both the problems are interesting. Okay, both the problems are very, very interesting problems to solve. And if you have answers for 1 and 2, then you will be able to design WhatsApp. Okay, so I will pause here, go through questions that are there on chat, and then I will proceed further. Let us see if there are any questions on chat. Socket, push, PubSub. Okay. Okay, I don't see any relevant questions right now. If you have any questions, feel free to write on the chat. I will be reading chat every 15-20 minutes. Okay. So yeah, some suggestions are we can use WebSockets. So we'll discuss about it. What are WebSockets? Why are WebSockets? So we will discuss. We'll go into some details there. Okay. So step by step, let us see. So now let us try to solve problem number 2 first. Okay. Problem number 1, we will discuss later. Let's try to discuss problem number 2. It is the fundamental problem that a server needs to send something to a client. Okay. And let's say I have, and how do I send it? Because I didn't receive a request from him, so I don't know what is his IP address and whatnot. Both problems are also in a way related, right? So let's see how we can solve it. How can I send something to someone who has not requested it? Okay. So currently there are 3 ways to do it. One is called polling. What is polling? Which I just discussed. So there is a client, there is a server. Firstly, understand the problem. Problem is that server wants to send something to, arrow is on from server to client. Server wants to send something to client, and it can't do because it does not know IP address of the client. So here is how polling solves it. What polling does, that client keeps sending messages to server every 5 minutes or 5 seconds. Is there some update? Is there some update? And it says no, no update, no update, no update. And the moment something is there, you receive a reply. So first question, what is the maximum latency if the polling frequency if is 5 seconds, then what's the max delay in
5 seconds.
receiving response? Okay, if polling frequency is 5 seconds, what is the maximum delay? So maximum delay, like somebody said, that maximum delay can be that server has something, and just before that, client had requested, does it have something? So it will say no. And then after 5 seconds, client will again request. So maximum delay you can see is 5 seconds, equivalent to the polling frequency. This is also a very important concept for you to understand. That if polling frequency is X second, then maximum delay is also X second. Which means if I'm okay with 2 seconds latency, I can poll every 2 seconds. But if I poll every 2 seconds, then how many polls do I make in 24 hours? How many seconds are there in 24 hours? We all know.
600.
This is the number, right? Divided by 2. So this is a good amount of number. And do you think client's only job is to poll the server? No, client has to also do other things, right? For example, notifications has to be read. Client has to also power the front end UI components, etc. Client has to also make genuine requests like authentication request, user profile request. Uh, it has to also take video calls and whatnot. Tons of other things are there in the client. So client can't always keep polling, right? And we are not just discussing about WhatsApp here. In general, whenever a server wants to communicate to a client, if you go via polling, then the con here becomes client becomes overloaded. Client becoming overloaded is a big issue because you don't control the infra of your client. A client can be sitting on a Nokia mobile or a very brand new iPhone. iPhone can do these kind of polling, but again, if iPhone WhatsApp uses so much of RAM of your iPhone, then your iPhone will not be, let's say, able to do other tasks like you are on a Zoom call also with the same iPhone. So if a lot of resources are being taken away by one app, that's not good, right? You will most likely uninstall that app because that is making your phone slower. So this becomes a very big challenge for any company today, that you can't have client side overload. Okay, client have to be very, very light. So this is the first thing that you can solve. Server to client communication can be solved via polling, but it has a problem. What is another way? Another way is called long. What is long polling? So now this is a problem. This is a fairly new problem, right? Chatting etc are fairly new problem, as in these have been solved in the last 20-25 years, right? That's what I mean by a new problem. So a server has to send something to client. So long polling is a modification on HTTPS. So HTTP creators, they understood that if server has to send something to client, today the only option is polling, which is also called as short polling. Okay, polling is also called as short polling. Keep sending HTTP request at every X interval, and if some update is there, you will get. Otherwise, you won't get. Next is long polling. So HTTP came up with a modification that in your header, send this keep alive. Send keep alive header, and you can set it. Let's say 5 seconds or something. So what happens? Your HTTP connection is kept active until 5 seconds. For example, client was sending every request, let's say 5 seconds here. Now what it has to do, it will send one request and it will be active for 5 seconds. So within that 5 seconds, if the server receives any update, it will say, yes, I have got it. And if within those 5 seconds, if no update has been received by the server, it will say timeout. Okay, so in 5 seconds, it will time out. Within that 5 seconds, if you get any update, server will reply back. So this is called HTTP long polling. HTTP long polling this is the most, I would kind of say this was the only option available until 10, 15 years back. So older applications, WhatsApp is a good benchmark. Before WhatsApp, all the chatting systems that you have seen worked on HTTP long polling. Do you know a very famous app that we all have used, which works on HTTP long poll? Google Docs. Google Docs today also uses, like at least 1 year back, it was using HTTP long poll. Okay. So Google Doc is also having the same problem. Two people are collaborating together. You will not go into that, but you should know that Google Doc today also works on the principle of HTTP long polling. Okay. So with a keep alive header. So now what is the advantage that we are getting here, right? With short polling. So in short polling, you had to keep sending messages, right? Every interval to know if you have gotten or not some update. Here, one connection is kept active for 5 seconds. So you don't need to poll in between those 5 seconds. Any update within those 5 seconds will be answered. Whereas in short polling, immediately response comes, yes or no. Okay. The connection is not held for any amount of time. So here connection is kept open. So this is also expensive. Okay, expensive compute. Because connection is kept active, that doesn't come for free, right? That connection is kept active, keeps your CPU busy, etc. But client side compute has been saved. That is the biggest advantage that you get with HTTP long pole, that the load has been shifted from client to server. Server is holding the connection. Server's time is being wasted. Server can be scaled. Server infra can be controlled by WhatsApp, Google, whoever is owning that. But client infra can't be controlled. So now client has number of requests that client has to send reduces. Okay. Number of requests client has to send reduces. So long polling is a very good mechanism. In fact, it is also currently used by a lot of apps to solve server to client communication. Okay. So this is a good mechanism to do server to client communication. Now, 10 years back, hardly 10 years back, very new, a new concept came called WebSockets. Anybody knows WebSocket works on what application layer? Protocol in networking. Like long polling works on HTTPS, HTTPS. Short polling worked on HTTPS. WebSocket works on what?
TCP.
I'm talking about the application layer protocol. Okay,
HTTP.
so this is also HTTP. Okay, so now a good point to think here is, why did HTTP creators came up with WebSocket when long polling was there? What is a con in long polling that is being tried to, so I will not come to WebSocket straight away. Let's understand what problem is there in long polling, which is tried to be solved with WebSockets. Okay, so the problem is expensive compute. Keeping connections open on server side doesn't come for free, which means the people who have been attending my lectures will understand that if you keep a connection open, that means the number of parallel connections on a server increases, which means the availability goes down, latency goes up. That becomes an issue. And this was noticed by the creators of HTTP. And to be precise, WebSockets work on HTTP 2.0, was initially designed on top of 2.0. Now it is also available on 1.0, I think. But yes, it is built on top of HTTP. So, and the problem that they were trying to solve is the expensive compute that servers were doing by keeping the connection open. So WebSocket is trying to solve that problem. Okay, that again, and one more thing is, it is still polling. Okay, remember, still client has to initiate. So the number of requests client is making has reduced. It has not eliminated. It has been reduced. So here, if you are making 1,000 requests, here you are making 100 requests. So both problems is still there. Okay, client still has to poll, and client polling is very dumb, right? For example, let's say I am on a vacation and I'm not using WhatsApp. Imagine WhatsApp is still sending hundreds of requests via HTTP long poll to WhatsApp servers. Did Aditya receive any message? Did Aditya receive any message and whatnot? Right? So keeps doing that. Even if nobody is messaging me, because everybody knows I am on leave and nobody is messaging me, but it will keep messaging. It will keep asking WhatsApp servers that is any update available for him. So that also becomes very tricky. Another problem, another very important problem. These are two very small problems. One very important problem is when two people are online. Okay, understand. Two people chatting. I message you, you are offline. You see the message, you reply me, I am offline. So basically, we both are chatting asynchronously. Okay, but if two people are online and they are chatting, we all have done that, right? A and B both are online and both are chatting, and this becomes a real-time chatting problem. So when this real-time word comes into picture, long polling goes for a toss. Why? Anybody? A sent a message to B, and B is polling WhatsApp servers. Did B receive any message? Every 5 seconds it is sending. So that may cause a delay, right? Sometime the chatting experience can be degraded here. Either you cover the entire 24 hour, like 5 seconds you sent a message, you got timeout, immediately again you sent. So without any, you keep sending throughout the day, then that means you still overload the client poll. If you introduce a delay between two long polls, then real time goes for a toss, right? So it becomes a very tricky trade-off. that if I reduce client side polling, then real time is not guaranteed. If I guarantee real time, then client side polling becomes the issue. Client keeps polling continuously. How to solve this? So on a fundamental level, HTTP tried to solve this, that okay, short polling is not an answer and long polling definitely is not an answer. It's a basically optimized short polling. So they came up with something called as WebSockets. Okay, what are WebSockets? Now we will try to understand what are WebSockets. Okay, so WebSockets are basically that you have a client and you have a server. You send a simple HTTP packet. So are you guys aware how a HTTP connection is established? It happens via three-way handshake, right? So firstly, you send a SYN, you receive a ACK, and then SYN plus ACK, and then handshake happen. Okay. So I will not go into that detail. Let's say HTTP handshake has happened via the three messages exchange. Once the handshake happens, server in the acknowledgement, in the last packet that server sends, in that acknowledgement, he can send a header on HTTP, and the header is called upgrade. What is the header name? Upgrade. This is very important. In a HTTP connection, if you send a header upgrade, then the connection gets upgraded to a WebSocket connection. And what is the WebSocket connection? WebSocket connection is a bidirectional connection where both client and server can keep sending and receiving messages. Channel is open. Now, this is not a typical HTTP connection. So once an upgrade header is sent on HTTP, after HTTP handshake has happened, if a server sends a HTTP upgrade header to client, then the whole connection gets switched to a WebSocket connection, which is a bidirectional channel, which means client can send message, which means a connection is established. Now, see, now here what was happening in short polling, connection was being made, server replying no, connection broken. New connection made, server replied no, connection broken. So every time you are sending a request, you establish a connection. Once you receive the response, connection is broken. Okay. So every request response is one connection. Same thing was happening in long polling also, only request and response, there was a lag between, okay, because of the keep alive header. But once that header becomes upgrade, then the connection is kept open. That connection does not go. That connection remains active between server and client. And now, because this connection is not left between client and server, both can ask and both can communicate. Now, client can send something to server, which is which was possible in a typical HTTP request as well. But now server can anytime send anything. It does not depend. Without client requesting anything, server can send response to C. And in that way, we should not even call it a response, right? Basically, server and client can exchange messages now. Concept of request and response you should remove from your mind when we are discussing about WebSockets. So now, if server wants, can communicate anything to client. Okay. So now with this knowledge, now we will try to approach the problem that we are initially trying to solve. What was the problem that we were trying to solve? The two main problems that we were trying to solve was that how to find B, we are yet to solve that. And the second problem, how to send a reply without a request. Now we know how, right? We have two options, basically today, long polling and WebSocket. And now we know WebSocket came after long polling. So obvious, and it was made by the same people, HTTP, okay? Association of Networking. Basically, the International Association has accepted this proposal on top of long polling. So long polling has been kind of, you can say, deprecated and has been succeeded by WebSockets today. But today, if you want to do a server to client communication without a request, you should be inclined towards WebSocket. Still, there are use cases where you would prefer a long polling over WebSocket, but that's a long and a different discussion to have. So now you know two ways, long polling and WebSocket, via which server and client can communicate, with the last option, WebSocket, being the most popular and the most latest one. Okay. So now we know how server can communicate. So now let's go back to the problem that we started with. A is there, B is there, one chat server is there, let's say. A sends a message to B Okay, send message to B, chat server receives it. And now if chat server has a WebSocket connection with B, it can forward this message to B. But the thing is that the moment A sends a message to chat server, at that time you should not do a handshake and establish the WebSocket connection. That will again not make it real time. Connection should already be active between B. These are very important things. So this if concept, if you understand, then designing WhatsApp will become easy. So if the connection is already active between B and the chat server, which means a double duplex connection slash WebSocket connection. WebSocket connection is also called a double duplex connection. So if a WebSocket connection is already established with B and chat server, then the moment A sends a message to chat server and chat server receives that it has to send message to B, immediately it can send. Okay, now this will be real time. But to make it real time, as we have understood, WebSocket connections must be already active. So WebSocket connection should be already established. Okay. So you do not establish a WebSocket connection the moment it sends a message to B. WebSockets connection must be active always, so that all communication is real time. Understood? This is the most important takeaway from here. What about A and chat server? Should this be HTTP only? HTTP type of request? So this is WebSocket, which is upgraded HTTPS. Should the communication from A to chat server still be HTTP, or should that also be WebSocket?
It can
Anybody?
be bidirectional, so it has to be WebSocket. Chatting can be bidirectional.
Correct. Good point. So what if now B replies to A? So again, same problem will happen if there is no bidirectional channel between A and chat server. Now, we also understand that not just receiver, even the sender, both the sender and receiver, both A and B have to have a bidirectional channel with the chat server. Okay, this is not a final design. This is just a POC that we have done. We will move through and we will try to see what are challenges in this design. So this is design number 1, right? That we have one chat server and 2 clients are trying to, and this is something which you can also make, and it will hardly take 2 to 3 hours to make this. You can create a chat server which opens WebSocket connections with all the clients, and then A and B can communicate via the chat server. Okay. Now, before moving forward, I'll see if there are any questions. Let me just go through all the questions. How many WebSocket a server can have at a time? We will discuss that. Doesn't WebSocket increase the delay due to too many open connections? Of course it will. We are yet to discuss that. How the WebSocket connections get established. So Akash has asked a question which is relevant to whatever I have discussed so far. So his question is how WebSocket connection gets established. So Akash, how it gets established is a normal HTTP connection is firstly established between A and B. How a normal HTTP connection is established between 2 parties? Via 3-way handshake. Okay, go and read about it. We all would have studied in our engineering. So far, you know that a normal 3-way handshake is done. After that, if the server sends a upgrade header, a HTTP packet with an upgrade. So in the last, so basically, if you read how HTTP connections are established, firstly a SYN packet is sent, then an ACK packet is sent, and then SYN plus ACK is sent. Okay. So once the server sends the acknowledgement packet, in that if server sends the header upgrade, then the connection becomes a over HTTP, it becomes a WebSocket connection between A and B. Now, this connection will never be closed. Now, A and B can keep communicating. So this is how WebSocket connection is established. Hope that answers your question. At what time WebSocket connection will be closed? Good question. We'll come to that. These are all good questions. So far in our design, we do understand that so far, what we do understand that a WebSocket connection must be established with the chat server between the 2 parties. Okay. both, if A is sending to B, both of them should have a open WebSocket connection with chat server for the chatting to be real time. Whether the connection is closed or not, you will get to know once you watch the entire, once you go through the entire session. Okay, I'll not jump straight away to that. Good. Okay, I hope rest all questions should be answered. Great. So now let's move forward. So one question, good question was asked, that what can WebSocket connection be closed all of a sudden? Of course. What if internet outage happens at A? Socket will be closed. Chat server goes down. WebSocket will be closed. So all of that is possible. We'll come to that. Okay. For now, let us understand the basics. Okay. So we know that WebSocket connection is important to exist between. Let me erase this explaining thing first. Between A and chat server and B and chat server, so that A and B both can communicate in real time. Okay. So if A and B want to communicate between each other, then they have to communicate via chat server of WhatsApp. This we all agree. And both of them should have a existing WebSocket connection if they want to do a real-time chatting. Okay. So far we are here. Now let's see what are problems with this design. A few of them have been already pointed out, but the main problem here is, if this is the only chat server, so if C and D are talking, they are also establishing connection with this. E and F are talking, then they are also establishing with this. Now, keeping a connection open on HTTP is expensive, right? So these chat servers are anyways running very, very hot, and more people are making connection requests. So if you create such a system and your system catches popularity, your server will go down. So here problem becomes load. Okay. Single point of failure. Firstly, if you have only one server, it becomes a single point of failure. Now, a simple solution of single point of failure, which people give, have two of them. Okay, fine. Now, let's say there are two chat servers. Okay, let's say there's a group of 4 users, A, B, C, D. Okay, and A wants to talk to B, and A also wants to talk to C. So now, let's say there are two chat servers. So A is connected to chat server 1, B is connected to chat server 2, and A and B want to talk. A and B want to talk. So A has sent a message, but this message has gone to chat server 1. And now chat server 1 can't send a message to B because there is no WebSocket connection between B and chat server 1. There is no connection here. Okay. So now how will you solve this problem? How do you solve this problem? Now B and chat server 1 are not connected, right? So here, if you try to horizontally scale, then you need to solve the problem of identifying where is B, which was the first problem. Which
Can
was
be
the
some
first problem.
like-
How to find B. Okay. I'll come to your questions. Let me finish this part first. I'll take all the questions. Okay, so we need to figure out how to find B. This is still left. And this is what has been highlighted when we try to scale the chat server. If we have 2 of them. Now, is 2 of them enough? How many should we have? If there are 50 million, now comes, yeah, good. Now let's come to estimation. Let's not throw numbers, let's do estimation and then see. If there are 50 million daily active users, let's try to estimate how many users will be there on WhatsApp. How many users will be there on WhatsApp?
Maybe more than 1 billion.
Okay. So let me give you a simple problem statement. Okay. Let's say WhatsApp has 100 users. Should WhatsApp have WebSocket connection with all of these 100 users? For some, it will anyways not be able to have because their devices are not online or they have not opened the WhatsApp app. In those cases, the WebSocket connection is anyways not established. So what do you do in that case? Okay. So now there are 2 design problems here. Firstly, should each user and WhatsApp server have a dedicated WebSocket connection? Okay, 1:1 WebSocket connection between user and WhatsApp chat server. What is a chat server? That we also will come to that. Okay, so between one user and one chat server, one WebSocket connection should be there. Now, WebSocket can't be, anyways, it can't be like it has to always be one to one. Between one server and one client, only one WebSocket connection can be made. So that possibility is anyways not there. So one design is this. Another design is do not keep a WebSocket connection open. Open it only on demand. Okay. So there are two choices which I'm giving you. Keep connection open always. And second is on demand. Now, where are you guys inclined? And we will discuss the pros and cons of each. Before that, let me see if there are any questions. Okay, no questions. So let us discuss on this. What design is good design and which will cater to our requirement? Should we always keep a
Both.
WebSocket connection open or should we do it on demand?
Both we can do, like
Okay,
when
so
there is
let's
real
say
time.
on demand. So what criteria will be on demand?
When someone is offline for some time, that time on demand. And if
If
they are
somebody is
continuous,
offline, then you anyways can't have a WebSocket or any kind of connection. Even HTTP connection can't have that.
Last
So
used time we can maintain and
no. Okay, so I think there is some confusion that only if he's. What about push notifications? If A send a message to B and B is by offline, I mean he's not in internet. If you are in your Wi-Fi network, your mobile is let's say on your fridge, and I have sent you a message, you will still get the push notification. Yes or no?
So
Which
what we
means
can
the WebSocket connection is anyways there. Yes. Any other
what
suggestion?
we can do is, like, if there is no communication between by the user A, like user A is not sending the message, we'll terminate it. If there is another user, like user A, there is a communication with the user A and B. A is sending messages, right? So will maintain the, we have 10 minutes or some interval of time, we observe that, like, WhatsApp server observe that, like, A is not sending the messages, so we'll disconnect it. But
Okay.
if another user B is trying to, or C is trying to send message to user A, in that case we can recreate a new connection. Yeah, like, to recreate a connection, there might be some efforts will be there, like we have to do 3-way handshake, but as we are saving so much resources, so it's fine.
Two problems there. In what you have suggested. Firstly, good, like thinking wise, you are on the right direction, but you missed one thing. So if A is sending messages, you are saying that then we will keep the WebSocket connection with A to chat server open. Okay, that is fine. I agree to this statement. But you said that if A is not sending messages, let's say for X amount of time, then remove this WebSocket connection. Here there is a problem. Now, what if B has a WebSocket connection with chat server 1 and has sent a message to A, which means there is no way chat server can send message to A. It's not only not practically, theoretically, it is not possible, right? Now, if I have stored a message, best I can do is I can store that on this user ID of A, I have received this message. Whenever next time a WebSocket connection is established, send this message. But how will that connection be established? That will only be established when A comes back online and his client app requested a connection with chat server. But that's not how WhatsApp works. We all know, right? If I message you, if you are
Yeah.
online, you will receive a push notification, right?
But what I'm saying is, we will like a chat server, like, can't chat server makes a connection with A, user A,
How
like,
how will he know the IP of A? If how can chat server make a fundamentally we discussed, right? How was a WebSocket connection established? A did a handshake with chat server, then the
yeah,
connection was
got
upgraded.
your point. Got your point.
Right. So it is theoretically impossible.
We can keep
Okay,
the
so-
connection to
So answer is, unlike the popular opinion, we have to keep the connection always open. Okay. And the reason is that WhatsApp allows real-time notification also, not just real-time chatting. This is the key. It also does real-time notification. chat notification don't come 30 minutes late. Okay, this is also real time. If I remove this requirement, you can go to on demand, which means next time A opens his app, what I think before someone was suggesting, his approach will work then. Like chat server can store that he has received all the messages, like a list of messages that has been received by A. And the next time A opens his WhatsApp app, the client will send a handshake request to chat server one, establishes the double duplex connection. Then all of these messages will be routed to A. Okay, so see, here is what you have missed while you were not on. Okay, so that can work when real-time notification is not a criteria. So this is a good point to bring up in the interview, that do we want to support real-time notification? Yes, then we will have to keep a connection always open with all users and the chat servers. If no, then we can do on demand. Okay, so you are on the right direction, but yes, yeah. So the keyword was here that if we want to support real-time notification, only then we need to have a connection open always.
So I have doubt here. So
Yes.
For the push notification, we can have a separate connection. What I mean to say is the WebSocket connection between the client and server. You can use it for the chatting purpose, like just the message. But for the push notification, like when the user is getting the notification, right? So will that connection be different from a WebSocket, or it'll be the same WebSocket only?
So to answer your question, push notification request should always will not be via the WebSocket channel. So push notification request has to be sent by a third-party service to A, but that has to happen real time. So A has to send his device token to. Basically, point here is that what you are trying to say is that should WebSocket connection be necessary for push notifications? Am I correct? This is your question?
Yeah. So that
you agree that WebSocket connection is necessary for real-time chatting, but your question is for real-time push notification also is the WebSocket connection important, right?
Correct. So that if we separate it out,
Okay.
you don't need to establish the WebSocket communication. So something like lazy. So only when required, I'll establish WebSocket. Otherwise, I'll not. Something like that.
Good point. Okay. So now this is where I was going next. So now let us try to see real-time notification. Let's deep dive on this. Okay. So real-time notification, when I say, now you need to understand what channels via which we want to support real-time notification. Now, one real-time notification can be push notification. Another real-time notification could be WhatsApp, like non-push notification. This is also there. Okay. So one is push notification. We will come, and then another type of notifications are non-push notification. Now let's see the difference between both of these properly. Let us understand what is the difference between both of them. So push notification, we have studied this before, that push notification is done by Apple or Android via their third-party services. WhatsApp can't send a push notification directly to iOS user. They have to do it via something called APNS. Okay. So the provider has to send a request to APNS, and then APNS will send the request to the mobile client for a push notification. Firstly, let us understand this, that today provider can't directly send message to the client for a push notification. This is impossible. It has to be via Apple push notification service. For Android also, it is behind FCM, which is Firebase Cloud Messaging. Same thing, provider has to send it via Firebase Cloud Messaging. So direct communication between provider and client is not there for push notification. But what are other notifications which are not push notifications? Anyone? What are non-push notifications in a mobile? We all know what is push notification, right? Once you open your mobile, then whatever, the icons which come in before the lock screen opens, they are push notifications. But then there are some non-push notifications, right? Now,
OTP?
non-push, yeah, that is one real-time notification. OTP is a real-time notification, right? SMS
Location.
is another real-time location. Yeah. So now we need to see that real-time notification, WhatsApp, what is WhatsApp offering in real-time notification? Is it push notification or is it non-push notification? So next, this you need to discuss with the interviewer, but we all know that WhatsApp supports push notification. Okay. So now this was the next logical conclusion that you need to make here, that if the real-time communication, real-time notification is there, now you need to see whether you need to support it or can it be supported by third party. So push notification can be supported by third party. So now you don't need a WebSocket connection. But if it is a non-push notification, which is SMS or many more things, these can also be done via third party, and these can also be done via first party also. Okay, one more very nuanced, I don't know if somebody has noticed, in your app, there is a red icon on top of it saying some notifications are there. I don't know if anybody has noticed that. So that is a provider sent notification. Okay, that is not push notification. Have you noticed this? That icon is there and then something is on top of it. So that is not via APNS. Okay. So there are many types of notification. So here we need to understand that. So if the only real-time notification that we need to support is push notification, then also, now this is the key here, then also we can do on-demand WebSockets. So now let's understand.
Basically, even in push notification, there is going to be a WebSocket connection with the Android Firebase service or Apple service, right? So that is going to be just like how the WebSocket is.
No. Okay.
It's going to be
So,
single for all.
yeah. But let's not. So we will only talk about WhatsApp's design. So if Firebase is establishing a WebSocket connection, but point is that you don't establish a WebSocket connection with the chat server. This is what I'm saying.
Correct. Okay.
Right. Okay. So let me conclude this properly before you get a little more confused. Let me conclude this properly. So if there is a need for real-time notification, then you have, in this case, we firstly notice that you need to have WebSocket connection. But then you need to ask whether this real-time notification is supported by a third party or you need to support it, first party. Third party notifications are push notifications. Classic push notifications, they are supported by APNS and FCM. Firebase Cloud Messaging and Apple Notification Service. Now, first party messaging are hundreds of other things. Okay. And this is something where innovations are also happening. Okay. That red icon on top of your app or something else, whatever it is. First party notification is also a real thing. So if first party notifications are not there, third party push notification is supported, then you don't need to support or you don't need to make your chat service busy with that. So now here, what we are concluding at, that if A is there and B is there, and there is a chat server. Now let's say there is no WebSocket connection between A and B, but there is a WebSocket connection between A and chat server, and they both are communicating via double duplex channel. Now A all of a sudden sent a message to B, and chat server found that there is no WebSocket connection between B and chat server. So now the only option it has that it will send via APNS, it will send a push notification to B. Okay. But now here also you need to make sure that the WebSocket connection is only not open when B is not online. Okay. So let us understand this. Let us conclude this with 2 points, that we can do on-demand socket creation, and we can do on-demand socket creation with third-party real-time notification. Okay. So this is one option that we have. Second option is we always keep WebSocket connection open, this is always the option that is available to us. Now we are having two options. One is this that I just said, that if the WebSocket connection between B and chat server is not established, then it is routed via APNS. But here is the slight nuance. It should not happen that B is using B is using WhatsApp, and still the WebSocket connection is not established. Okay, so this we need to take care that the moment B starts using WhatsApp, we immediately create a WebSocket connection, so that at least when he is using WhatsApp, then a push notification does not come, rather inside in-app notification come. Okay, this is what I was talking about. Real-time notification are of two types: push notification and non-push notification. So here, non-push notification will come via the WebSocket route. Okay, so the nuance here which I'm discussing is that let's say you are using your mobile phone and WhatsApp is open and some other apps are also open, and now somebody sends you a message, so you don't get a push notification, you get a WhatsApp notification, first party notification. Okay, this is the point which I was trying to make. So now I hope thing is clear that we can have on-demand socket creation, but we need to make sure that B and chat server always have a web socket open when B is online. Okay. So with this, you can save the number of WebSocket connection you can have. What is the problem in design 2? Design 2 problem is that all users will always have a WebSocket open, which will be an expensive thing to maintain. Okay. So now with this, we will stop and we'll move to the next part of the design. Before that, I will take any questions if there is any. Online on demand, and can you find a scale? Okay. So there is one question. Once a push notification is detected, WebSocket can be reestablished by again. WebSocket can never be by A. Once a push notification is, that's a good point. We can think about it, but why would a push notification cause A to have a WebSocket connection with chat server? Maybe he is not going to see WhatsApp at all, right? Once he clicks on a push notification, then I agree with your statement, right? The moment he says that he's online, and by online, now by the terminology of WhatsApp online, what is WhatsApp online? WhatsApp online means a WhatsApp tab is open. Okay, so that online and offline now we will be discussing, because now fundamental concepts are clear on WebSockets and HTTP and on-demand messaging. So now online means WhatsApp online. What is WhatsApp online? If WhatsApp is open or not. So what was the last time you opened WhatsApp is whether you are online or not online. Will chat service provide IP details to APNS? Again, we will not cover that because we have already discussed notification system design. We know APNS works. Can I already answer how APNS works? APNS works on mobile number. Options are works on mobile number, IP address, and 3 device token.
Okay.
What does APNS work on? Answer is device token. We have discussed this before. So again, we will not deep dive there. That's the reason I covered notification system before teaching chat. Okay, so now we have dodged a lot of important points, and now we have quite a lot of resources with us to help design this problem. So we know we can have on-demand WebSockets. Point number one, we know we need to have WebSockets. We just need to solve this problem, that when we horizontally scale the WebSockets, A is connected to chat server 1, B is connected to chat server 2, A sends a message to chat server 1. Now, how does chat server 1 figure out that it has to send this message to chat server 2? Okay, so chat server 1 can't figure it out. Answer is because chat server's responsibility. Now we will come on design, HLD. Okay, now we will discuss what is a chat server, what kind of entity is it. It is a service or it is a worker or what kind of. Okay, so now let us start our design. So these are your users. Now users will still have to do some basic things like profile creation, authentication, authorization. All of those don't require a WebSocket. Do we agree on this statement? Typical generic work like authentication, authorization, login, logout, profile creation. These are not WebSocket. WebSockets will be used during chatting. So for other purposes, what is the first layer between client and a third party? What is the first interface where a client
Gateway.
interacts? Yeah, first is API gateway. Good. So we have API gateway. So this is for all other aspects from chatting. We will just leave that design because anyways we don't need to deep dive there. But since we are making HLD, let's make it good enough. What's the second layer after API gateway?
Load balance.
Load balancers will be there. After load balancers, you will have all the API servers. Okay. So what kind of APIs, what kind of API, like services will WhatsApp have? Like user management. Then there will profile. Then there can be auth, right? Then what else? XYZ, right? Multiple things will be there. We don't need to deep dive there. Okay. So all non-chat related are done via the traditional HLD. Okay. So the request to reach one IP address, which is the API gateway IP address. From there, it reaches load balancer. Load balancer finds out which server should it redirect the request to and sends the server based on the API call which is being made. And the response is sent back to the clients. This is plain and simple. We have already covered this. Now, let us talk about the chatting scenarios. There, what will be the system design? Okay. So now imagine there are multiple planes on this blackboard because I can't draw this in one place. So understand, like imagine it is a 3D model. And on top of this, we have another layer of WebSocket connections. So now we will discuss on the chatting part. A, B, and C. Now, A will also have some WebSocket connections, which we have already figured out. Now, what are these chat servers? Okay. So let us understand. So WhatsApp or any messaging platform will have its chat servers, which is a fleet of servers which the messaging platform maintains. We'll have chat server 1, chat server 2, chat server 3, ... chat server n. This is a very interesting problem. And I will tell you what is interesting and what is not interesting in this. So now, question number 1. How does A send a handshake request to chat server 1? How does A even know chat server 1 exists? Because we all know www.whatsapp.com is this API gateway. Or anything.com is always the API gateway, right? Internal server you can't hit directly. Do you know IP of any server of WhatsApp? You'll never know that. Okay. So how can A establish? Now these are very fundamental questions which people don't think about. So let us see. How will A establish a WebSocket connection with chat server 1? It does not even know chat server 1 exists. Anyone?
Load balancer decides it, right?
No, but how will load balancer decide it? Load balancer will simply, if you are sending a request to whatsapp.com/auth, then what will load balancer do? It will send the request to auth, whichever many servers of auth is there, whichever is having least load, it will send there. That's the only role of load balancer. Load balancer is not having any logic. Now here the question is, which chat server, like how can A figure out CS1?
Yeah.
It has to be via API gateway, right? The only connection it can do is via API gateway. Now, from API gateway, how do I come to CS1? This is the question, basically.
Like there is a concept of sticky sessions and all. Using like session management logic, we can make sure that A will
But first connection, how do you establish the first connection? I understand sticky session. You may be right there, but how will you even make the first connection? How do you know chat server 1's IP, even if it exists or not? A can only interact with API gateway. How does it know about chat servers that I have? Fleet of chat servers that I have. How will A come to discover them? He can't know about it, right? So there on, yeah, okay.
So,
Then?
so okay. So like similar to here, we cannot use the same mechanism like concept of like service discovery and load balancing.
Correct.
We
Yes.
can choose one chat server.
Right. So answer, you gave the right answer. You have to use service discovery. Okay. So some service discovery has to be done. So basically the API endpoint here will be find chat server. And when this request reaches the API gateway, gets directed to this microservice of service discovery. And now service discovery figures out whichever chat server is having less load, it will assign that. And now this is how A knows the IP address of chat server 1 and then does a handshake with chat server 1. It sends an acknowledgement packet with upgrade header, and then they establish a double duplex connection. Clear? Similarly, B can establish with CS2, C can establish with CS3. So how is it happening? The moment you are opening your WhatsApp app, it is sending a find CS. Now, of course, this will not be the same API. It is sending a API call to the WhatsApp servers, which is getting redirected to a load balancer from there to a service discovery, and then what is a service discovery? Now let us talk about this. What is service discovery? Service discovery in this case, I'll not use a generic term here. Basically, let's say that it is a microservice whose work is to find which chat server is free and send the IP address of that chat server to the client who has requested find CS. Simple. Now this is a solved problem. Okay, this is a solved problem. You don't need to write code for this. There are many third-party apps. One of the most common is called Zookeeper. And Zookeeper is made by whom? Anybody knows?
Apache.
Made by Apache. So you can have Apache Zookeeper on top of your chat server, which is behind the load balancers. And the Zookeeper can redirect you to the correct chat server in which you should connect. Okay. So this way, A connects to one of the chat server, B connects to one, and C connects to another. And every time they open, they can connect to a different chat server. I hope now things will make sense. That how A connects. This is fundamentally how things work. Okay. And I'm saying this because we will have a demo of this. We have, like, not today. In our course, we will do it where we say we create a chat room and we will show that how we create chat rooms and how WebSocket connections are established, etc. We have our own small WhatsApp kind of service. So there you will see how all of these stitch one by one together. But right now, let us understand the high level design. So we have Apache Zookeeper, which listens to all the chat servers, and this is how first problem is solved. Discovery of chat server is solved. Now we were discussing that A wants to send a message to B. Okay, send message. Then you have a message, and it wants to send to B. So now this request. Now let's say B. By whenever I say A and B, think it is A ID and B ID. Basically user ID. Okay, so it is sending message to B, and this request comes to chat server 1. Now chat server 1 firstly has to, now there are many things here. See, message is fine. Message as it is, I need to relay. I understand that. Let's not talk about encryption currently. Let's see raw messages are being received. I can see everything. And now you have sent me B. So WhatsApp will have like phone number will come to chat server 1. From the phone number, it needs to figure out the user ID or let's say it sends user ID, whatever it sends. From the user ID, I need to locate B's map to which chat server, because now the communication has to happen via chat server 1 and chat server 2, because bidirectional channel is open between B and CS2. So they need to communicate. And chat server's role is not to figure out other chat servers. So we need another service here. Okay. Chat server's only role is to receive and send messages from it. And we will not have any other role. They will not have any other role. So now chat server 1 has to send this call to something called a messaging service. This is a microservice. Okay. Messaging service. First thing. So what is the role of messaging service? It will receive the message and it will persist the message first. Okay. What if B is not there? What if anything happens, right? It will persist the message so that reliability of the system is there. Whenever system is up, we will send the message. So it will store them. We will talk about the schema of this database later on. But right now, understand that we need to have this. Okay. So we have done this. Now, messaging service has stored the message in a database. Now, still the problem is unsolved. How does messaging service figure out that B is connected to CS2? So this messaging service will not solve. Now we need to have another service, and this service we will call presence service. This service's role is not just to find out A is connected to which chat server right now. Its also role is to find out whether it is like whether A is online or not. Okay, so this will have a greater role than just this is small thing. Let's see what. So now what presence service does. So whenever a client application is connected to chat server, firstly they will send message then that we are yet to solve that. Now, whenever A connects to chat server 1, right, via this find CS flow, the moment it establishes a connection, the chat server sends that, okay, I have established a connection with A. Chat server sends this to presence service that, okay, store this information. That A is connected to CS1. So presence service is doing that work for you. Okay. Similarly, B will also send to chat service. C3 will also send. CS3 will also send for C. Everybody will send to presence service. So now the problem is that I am sending a send message B got to chat server 1. Chat server 1 forwards the request to message service. Message service is only interested in the messages part, stores it in the database. Message goes there. Of course, with who is the sender, who is the receiver. We will discuss the schema later. But now it knows that the message is for B, and now messaging service will call presence service to know where B is present. B is present in chat server 2, and now with this information, messaging service will call CS2. So now let's draw a proper HLD diagram for one-to-one chat is solved. So let us draw a proper HLD for this. Okay. Which means arrows etc. I will make sure that they are done properly. So these are all your clients. These are your fleet of chat servers. I will not discuss the part of Zookeeper that you already know, how the connections are established. CS1, CS2, CS3, so on and so forth. WebSocket connections are established. And this is the HLD for one-on-one chat. So see that carefully. The moment a connection is established, chat server will send a request to presence service. Presence service has a mapping of client to chat server. Okay. So client to chat server mapping is stored here in this database. This will be sent by all the chat servers to presence service. Now the next service, microservices, messaging service. Whenever a message is sent, then that message has to be forwarded to messaging service, which firstly persists the message in a data store. The schema we will discuss later. And queries presence service to find out where messaging service has to route. And then this actually goes and gives the message to that specific chat server's IP. And then this is how A communicates to B. Any questions on this? One-on-one chat is almost solved. The next part will how message statuses etc. are decided. But before that, any questions on this?
Here in the messaging service and chat servers, in between also going to be a WebSocket connection because we need low latency, right? Real time.
No. There will be no. Why do you need a WebSocket connection between chat server and messaging service? I didn't get that part.
We want that real time, right? When the moment A sends a message, it has to go the real time to B, right?
Yes. So see, understand, WebSocket connection we did not make because HTTPS is not real time. I hope this is at least clear. We had to use WebSockets because server can't send a reply to any client without a request.
Okay, I understand. So one
Okay.
more thing here is the latency to make a new connection also will not be that much. So it can work with a normal, some
Yeah. In normal HTTP call. Okay. So this is
normal
a
HTTP or even any TCP type of connection or RPC type of connection also will work, I guess, because both are in the same network.
yeah. That is fine, but you're right. Okay. But for the sake of easiness, and this is the normal what these are all HTTP connections. Okay, single arrows are HTTP connections, double arrows are WebSocket connections. So don't get confused. Only WebSocket connections are used between client and chat server. Nowhere else WebSocket connection will be ever used in this design. Okay, these are all HTTPS connections. Okay, any other?
Will the user to the chat server change basically like a user A? The present
Every time
server
you
basically.
every time you close WhatsApp app, connection will get disconnected, right? Because now you're not opening WhatsApp app. So will your iPhone keep the connection open with WhatsApp server? No, right? So connection will get disrupted. And next time when you open, then how will it be established? We covered that, right? Once you open WhatsApp app, find CS will be covered, load balancer, Zookeeper finds out a relevant chat server to you and it allocates you to, this time it will allocate you to CSN. Yes. So now you make a WebSocket connection with this. That answers your question?
Okay. Yeah.
Okay.
Thanks.
So
This
how
is what
do-
we discussed was on-demand WebSocket.
So,
Next question. Yes.
Yeah, how do they estimate like how many chat servers they need to have it open? Is
Good
it
question. Good question. Very good question. I'm going to come on that. That is the next agenda. Okay.
Just a minute.
Yes.
Yeah. Can you explain little flow diagram from CS1 and CS2? I got like what is the use case of message service, present service, and message
Flow
service?
diagram. Yes, here it is. So firstly, this scenario, there are two scenarios. First is discovery. So for discovery, flow diagram is that 1, 2, 3, 4, okay, and then 5. Clear? First, you send the request to API gateway,
Yes.
load balancer.
Yes.
This
That-
is for
that's clear.
discovery. Now for chat. Chat, who initiates the chat? A, number 1. Then it goes to chat server 1. Chat server 1, number 2, goes to messaging service. Messaging service queries present service to find which chat server is be connected to, and then sends the HTTPS connection, HTTPS request to chat server 2 that this is the message. And because the WebSocket connection is open, sends the message to B. Clear? So 1, 2, 3, 4, and this is 5.
Yeah.
Okay. Now, a very good point was brought up by someone. How do we scale chat servers? Now, this is where things get interesting, and this is the difference between mid-level interview, senior interview. See, now what question interviewer will ask typically in an architect or principal level interview here is that you have allocated your chat servers. Okay, forget about going offline. We are not discussing that. Let's say that there are 100 million users, 100 million chat server are there. 100 million chat servers won't be there. One chat server will have multiple WebSocket connection. Like CS1 will also have connection with user D and whatnot, right? Okay, this part also you should know. Chat servers are not that bad compute that it will have only one connection. So multiple WebSocket connections will be there between a chat server. Sorry, anybody is not on mute. Can you please be on mute? Thank you. Okay, so multiple connections will be there. Let me draw it so that I can face the problem properly. Okay, so now this is the situation. Now the question is, who is this? Please be on mute. Please be on mute, guys. Please be on mute. Requesting everybody to please be on mute. We won't be able to cover anything. We have 30 minutes. Let me please cover everything. So now
Can I ask something?
No. So let me cover this part. Okay.
Yeah.
I will open up for question. Please let me complete what I'm trying to say here. So now you are having chat servers are there. One chat server is connected to multiple mobiles, okay, mobiles or laptop or whatever. Okay. So now the question that can get asked to you is, how do you scale this? Okay. For example, let's say that you notice that you are having 100, like CS100 is there. And now the number of active connections have grown. Okay. So 100 chat servers are handling 10,000 users. Now let's say all of a sudden something happened, spike happened, and 10,000 more users joined. And only 100 chat servers are there currently. So load will increase, load will double. So now, as the owner of this chat server, you want to add more chat servers in your pool. Okay. How do you add this? For example, I add 4 more chat servers. How do I reallocate the requests so that every chat server is having equal amount of requests? Any of anybody wants to answer this?
Yes,
How will
Consistent hashing.
Great.
Consistent hash.
Good. Consistent hashing. Good answer. So see, now we studied consistent hashing in database. They are used in chat servers also. Okay. So this is how you deploy. These are concepts that if you study well, you will be able to answer. Good. Happy with those who answered this. So we use consistent hashing here. Okay. That and this is not just for adding, for removing also. For example, we want to remove them, then we will also use consistent hashing principle. We have covered that. I will not go into deep there. Now, one-on-one chatting is solved. Now we will discuss in this diagram. We are going to discuss how to solve the status. Okay, status. So once a message is created by A, so you send a message B, you also send a timestamp, which is called time of creation. Okay, you send it to chat server. The moment your message receives to chat server, you receive this status. Initially your message is created with a status created. Symbol is this. Once it is received by chat server replies A that okay, it is received. Single tick. Now once it is received from chat server, it goes to messaging service. Messaging service queries present service. Present service gives the location of B, which chat server is B connected to, and then messaging service sends the request to chat server 2. At this point, messaging service sends the message to chat server 2 and also updates that this is now sent. Okay. All of these I will tell where these are stored. So this will also, now this will become double tick. Now the moment chat server 2 sends it to B, okay, there also, so you can decide, you can either mark it as sent when message service, and now this is a product question. I don't know where actually WhatsApp marks it as sent. I don't want to know. Let's say somewhere, either when it is sent to B, it sends, or the moment messaging service sends it to the chat server, it sends wherever sent is marked. Now the moment B reads the message, now this is where the WhatsApp front-end app will tell that, okay, message has been seen. Now, because this is a double duplex channel, now B will send that it has been read. Okay, the blue tick will come. Okay, I will have to use color now. So blue tick will be sent, and chat server 2 will receive this blue tick. And chat server 2, anyways, chat servers are talking to messaging service, so this will be communicated to messaging service. Okay. Now I was saying that we will design the database schema of messaging service database. So that becomes important to understand this thoroughly. So messaging service has a database which is storing the messages, and the schema for that is you have a message, you have a sender, you have a receiver, you have created time, you have received time, you have sent time, you have read time. All of these times are there, which will denote ticks. Okay, what we see as ticks, they are basically these. So this is how an entry will look like. Let's say a message hello has been sent by sender, which is A, receiver, which is B, created at 0800 AM. received by B at 0801. Sent, this is received by WhatsApp. Okay, received by WhatsApp at 0801. Sent by WhatsApp to user B at 0802. And read by B at, let's say, 10 a.m. All of these entries are stored in the database in this format. This is the database schema. Okay. Now you know the schema. And how are these being populated? Okay. Once I will draw the HID again so that you understand. This time I will draw it with arrow. Let's see carefully what WebSocket connection is between here, CS1, and here with CS2. A, B, you have messaging service, and you have presence service. Okay, these are the components, and now I will be using 1 and 2 and 3 and 4. Okay, message has been created. Firstly, this is the created time. Okay, TC. Here, time will be stored. Okay, so TC, this is the TC. This has been, so this is created by the front end app whenever you type a message. Okay, you see a small time is also mentioned. So this goes in the API call with the message and with the receiver, which is B, comes to chat server. Chat server gives the time when it received the message, okay, to A. That okay. Now this is the time when I received this. T received, TR. TR is sent here. So time when it has been received by chat server, that is also sent. So all of this information you can see on WhatsApp. Okay. After this, chat server forwards the message to messaging service. Now, once it sends to messaging service writes it in the database. Okay. So keep noting the flow diagrams, logs it in the database. Then it also queries presence service to find which chat service is be connected to, gets the chat server, which chat server B is connected to, and then forwards the request to chat server 2. At this point, messaging service, all of this is going in the database. Okay, so TC travels all the way. So when messaging service receives the response from CS1, TC and TR are already stored. Okay, so TC and TR will be written the moment first request comes to the messaging service. The moment messaging service does gets the data from presence service, figures out this and sends it to CS2, then it logs in its own database. It logs send time, T sent. Okay. This is where T sent is logged. Now, the moment chat server 2 in the WebSocket connection sends the request to B, and B says that I have read it, the front end app will basically say. So T read is again given by the front end app to the chat server 2. Chat server 2 will now send this data, and T read will also be logged here. Okay. So this is the end-to-end flow with time stamps and icon, everything. Now you know. So how do I know what is the status? For example, a message XYZ has been just by looking at the database. Sender is A, receiver is B. Time, let's say TC is mentioned, TR is mentioned, but TS is not mentioned and TREAD is not mentioned. So what is the current status? Not a hard problem to know. We know the current received by us. If TS is there, we know it is only been sent. And if TR is there, then it is a blue tick. Okay, so this is how using messaging service, we figure out the status. No other messaging is needed. No other microservice is needed. So when I ask this question in Amazon to architects and other people, they draw hundreds of microservices to solve every single problem. You don't need that many. Only 2 microservices are there. Chat server fleet is there, and I can solve entire WhatsApp system design with this. So this concludes our one-on-one chatting. Okay. And in the beginning, you guys were trying to include more and more things. Okay, so never do that. Even this took so much time. Now let's come to group chat. Anybody wants to take a try? How we can use the principle of what we have studied so far of one-on-one chat to solve the group chat problem. And once we solve this, we are done. We will cover all the aspects of our design. So how do we solve group chat problem? Anybody? Can I use the same design?
Is it a kind of a PubNub model we can use for the group chat, right? or separate message queue for each group?
Okay. So what is your like? Okay, good. Okay, let me break that down one by one. So you are saying separate message queue for each group. That is fine, but still, B, let's say B and C are part of a group. Both of them have to receive that A has sent a message. If all the three are part of a group, even if there is a messaging queue for a group, you need to still send the updates individually to B and C. I hope this part is also clear with everyone. Okay. And suggestion, messaging queue, but where do I draw the messaging queue in this whole diagram? Between messaging service and chat server, or where? Like you need
Between
to be
between messaging service and chat server, because messaging service will decide to which all chat servers we want to send to. So we will
messaging service will query. Okay, in a way, present service will give the chat service to user mapping, and messaging service will have that data with itself. Now you are saying that we can dump all of this in a messaging queue. Okay, so one design that is being proposed is dump all of this in a messaging queue. Now, who will consume from this messaging queue?
So, like what we can do is like we will have like okay. So there are two things which I can think of. Like I will think of easy ways. So we can create a topic for each chat server. So we can create a separate kind of topic for each chat server. In those topics we can send the message, but we have to do it redundantly. Like we have to send it in, like if there are 100 chats,
100 people, 100 replicas you will have to send, right?
Yeah, 100 replicas we have to send. Or what we can do is, like we can have a one queue, and we can use a concept of, we can use like messaging queue functionality itself, like in Kafkas and all. Like we can create a separate consumer groups. So using that functionality, like single messages will be there, it will be consumed by different chat
Understood. But you created a messaging queue to solve some problem, I'm assuming. But the problem is
that
still
UDP broadcast, no? The broadcast, there is a functionality called broadcast if you use an UDP, I think, maybe.
No. So adding to what was suggested, he suggested like let us continue that discussion. Whoever was suggesting like messaging queue discussion, who consumes from the messaging queue? This you left. Who consumes from the messaging queue?
Yeah. So that information, like assume that we want to send it to CS1, CS2, and CS3. So from the messaging, some can consume, and that information which has consumed and which has not consumed will be there in messaging queue. So that.
So you are saying that all the chat servers will keep polling on this messaging queue, is it?
Yes.
But that will not be real time then.
So and that will be real time, right? Like the moment the message is received, it will be polled by.
But why are you assuming there is only one group in the entire world?
Sorry.
There are thousands of groups, right? Millions of billions of groups are there. Now think in a scale. Messaging service is pumping messages in the messaging queue quite a lot. Chat servers are anyways busy with handling WebSocket connections with so many mobile clients. And now you are saying that they need to poll this messaging queue for whatever. So this won't be very efficient, right? You know that chat servers have limited compute.
Just want to say, discuss few things. Like, can we say that like from a single message queue, a million polls can be done, or that's not possible? That's not allowable. Like
message queue only one receiver, right?
Okay.
I think we can have something like a key value pair for each message, and then we can maintain a counter on number of users.
So what is your suggestion? One by one. So I understood your first question. First person who was suggesting, I understood your suggestion. I will comment on that. What is the new suggestion? You are talking about messaging, sequencing the messages, something, right?
Yeah. So the counter, let's say in the group, let's say 20 people are there in that group.
Okay.
So we will have in that message one value called 20. I mean number 20.
Okay.
And then the message service will take and then send it to the CS, chat servers. So based on whenever it is successful, then it will it decrease the count.
Got it. I understood both of your points. Okay, now let me comment something. Both suggestions are fine.
Can I say something on the top of first suggestion?
I understood your point. I think I understood. Okay, you can add. You can add.
Add on. So I am saying, like, if that is allowable, we can do partitioning so that we can have a multiple queues.
Firstly, from one messaging queue, multiple subscribers can read. Okay, so that is possible. You can also have partitions. Okay, now talk about partitions. Okay, so you will add based on group ID. I assume that's what you are coming to.
Okay.
I'll summarize your point. I'll summarize your point. I got your agenda. Okay, like I understood where you are going with this discussion. So there are two ways to solve this. Both have been said by two different people. Great, saved my effort. So one is via messaging queue. Okay, you can have a partition messaging queue, multiple messaging queue. All these designs are open. Okay, let's say multiple are there or partition is there. If you are using RabbitMQ, there is no concept of partitioning. Apache Kafka has that logic, whatever you are using. So what messaging server now does, for each group, there is a messaging queue. Okay, each group has a messaging queue of its own. This is in itself becomes a very hard thing to do. This is not possible. So what is possible? That we can have a fleet of messaging queues which serves billions of WhatsApp groups. Okay.
Yes.
And we scale and not scale. We choose that. Okay. Yeah. So which means you will have to have a microservice, which is a queue managing microservice, which only task is to map which messaging queue for which are groups. Now that becomes a good design. Okay. So what is the design? I'll just focus on the messaging service to chat server communication here. So in the one design, I'm not saying that is, no design is correct or not correct. Let's discuss both the design, then we will know. So now one is that we have a queue managing service, and queue managing service, what it does, that there are many queues. It has, let's say, hundreds of queues are there. And each queue serves multiple groups, G1, G2, G3. This serves G4, G8, G10. Let's say messaging service has to send it to send a message. A sent a message via chat server, landed on here, and now it goes in this messaging queue. So from this messaging queue is owned by queue managing service. Now queue managing service figured out, firstly, this was not directly dumped by the messaging service. Messaging service sent that, please dump it in the correct queue. Queue managing service figured out that and dumped the message in the correct queue. Now, queue managing service is responsible for scaling, adding more queues, reducing queues, and whatnot. Now, this is a good design here. Now, still, open problem that now you have chat servers. Firstly, your chat server can't poll. Okay, they are already busy. Chat servers are heavily overloaded with WebSocket connections. So we will not leave that responsibility on chat servers. Now you will have to have another service whose responsibility is to keep polling from all of this and transferring the message to the correct chat service. Now this becomes a okay design. But let us understand what this design has added on top of it. This has added latency, okay? Which means that if you are in a group, if you message something, your receivers will receive it with some delay. When they send it, you also receive it with some delay. So that real timeness goes for a toss, but you make it available. So you compromised availability. So you increased your availability and your latency goes for a toss. Like latency is high. High latency, but availability becomes high. Okay. So latency is very high, which means like 30 seconds or some gap is there, but your system is highly available, open to scale. Another suggestion which the other person was giving, don't have all of this. Have the same thing, same design. Only thing that messaging service has to do is that for a group ID, it needs to figure out what all members are there and shoot that many duplicate messages to chat server 1, chat server 2, chat server 3. That's it, right? The first design that should come in your head is that A sent a message on a group. So messaging service queries present service to find what all members are there in a group. Okay, let's assume that is done by present service for now. Although that won't be done. Like to find out all the group members of a group, another service can be created for that. Okay, so this is one design using messaging queue. Second design can be the client is there, chat servers are there, and then we will do a pros and cons analysis. We'll know what is good, what is bad. This is the group. Okay, this was done via this. Reached messaging service queried present service, got the address. Now, generally it gets the address like this. But when a group message is sent, then you can have a group service, group management service, GMS, which will give you all the members. Once you receive the member list, you query for each member in a for loop. You request the present service queue. Hey, tell me where is B, where is C, where is D. So let's say B is connected to CS2, C and D are connected to CS3. So now messaging service knows that I need to send the same message to B, C, and D, and I know where they are connected to. So now B will fire in parallel. It has to fire all of these messaging. This is another design. But now messaging service is doing a lot of things. So whenever a group messaging is happening, then a GMS is anyways there. So can I leverage GMS to do this work for, like, let's say messaging service only does communication to chat servers directly for one-on-one chat. And when it is not a one-on-one chat, messaging service queries GMS, gets the member, gets the IP address, and then GMS, using the IP addresses of the chat servers, in parallel, it fires the request. Can GMS do this? Now, this is something that you need to think about. What is the good design? Now, both designs are not good and not bad. Here also, this service which is consuming from the queue, let us name that something. This will also be group messaging service. Okay, these are both parallel words. This group messaging service is different from this. So this group messaging service is basically eating from the messaging queues. Now, it can have a fleet of workers, which it can scale, and they can parallelly start consuming from these queues and start pumping the messages to chat servers. This is design number one, which is fine. But because of the messaging queue, it becomes asynchronous and there is a chance of delay, but the cost is high availability. Here you have that real timeness is guaranteed, but availability will go for a toss because this guy will be running very, very hot. You have to scale this guy because this guy is constantly delivering multiple messages in parallel to so many chat servers. Okay, so this is the design choice that you need to make. I would pick this design if real time guarantee is a must. Okay, so if my priority is real time chatting, then I will prefer this design. If my priority is high availability, I'll prefer this design. There is no good problem to solve. And now you get the answer to the question that why there is a limit on number of people in a group. In WhatsApp, you cannot have group size more than X number of people. I think that X is 100 and something, 100 or something is that limit. So now you know why. Because this is not an easy problem to solve. Whichever way I choose, I either compromise on latency or I compromise on availability, and both are dear to me, right? So I make a product call here that this design or that design. If availability is a concern, I can prefer this. Then there's no right answer. Okay, and that's why in the beginning, if you see, we started off with a question: is there a limit on group size? And the answer was 100. Because there is a limit on group size, now that we know this answer, now which design will you prefer, 1 or 2? If you know that the number of people in a group is limited to only 100, then which design will you prefer?
Second is better.
Second you will prefer, right? So this is the answer to your question. This wraps up all the questions. Before I go back and I open up for all questions, let us see all the requirements initially that we had noted. So latency real time we are guaranteeing for, and how we are doing it using WebSockets and highly scalable systems. Storage, now see, storage we won't cover because there won't be any time in a actual system design interview to talk anything about storage, but we persist all the messages. Okay, we are persisting all the way in our design, we can store any number of messages. Okay, when we can limit that to, we can do some computation and we can limit the number of time, like let's say 5 years, all the messages will store, after that we won't. Multi-device support is not a problem specific to WhatsApp. We'll not cover that. Encryption, again, we don't have any time. Maybe we can cover that later. Message status we have covered. Let's go back to our requirements. Sorry, I should have gone here. So MVP we have covered. One-on-one group messaging. Message status is covered. Push notification is covered. Encryption is covered. Encryption we have yet to do, right? We will leave this. We will leave this for today. Encryption, we'll leave it. Latency, availability, scale, we have solved. Push notification, let's see where push notifications come into picture. So let us go back to our one-on-one chat design, which was here. Yes. Yes, it was here. So now let's say that A sent a message to B. Messaging service directed, found out from present services, found out. Let's say present service said that B is not connected to any chat server. Then what will happen? It can happen, right? Present service will say which chat server you are currently connected to, but it can also say that you are not, B is not online. Okay, so if B is not online, in that case, there is no WebSocket connection with CS2. So what does messaging service do now? This is a scenario for push notification. So in this case, messaging service has to talk to notification service, which we have already designed. So that design you can copy paste here. So it just forwards the request to our notification microservice that we designed yesterday. And this will make sure that a push notification is sent here. Okay. Is this clear to everyone? Now we have covered the entire design end to end. So now when A is online, B is not online, that part also we just covered, which means that WebSocket connection will not be established, which means present service say B is not connected to any chat service. In that case, messaging service will not send a request here. Okay. So the T sent will not come. It will just give a notification, and once the notification is seen, then you will get the reply. So this covers everything end to end. I will stop here and I will firstly go through the questions on chat first, and then if there are any more questions, I can go. So I'm going through a few questions. Mapping between customer and CS. Yeah, we are storing that. Present service is storing that. So we have already covered user to chat service mapping is stored there. How many connection chat server can make? Now we have already covered that. We will use consistent hashing to scale, and depends the configuration of your chat service, right? General question: if a 2-year experienced person knows all these similar to it, then what is the difference? Okay, that is a very abstract question. I will choose not to answer it. Status: maintain a group to user mapping. No, we covered group design. I hope now that is clarified. Whenever a group is created, maintain a group to user mapping. Group management service is doing that, of course, that has to be done. So whenever a user is sending a message, yeah, that's what we discussed. I think we are in line. Last question on chat: if a user A exit, let's say WhatsApp, the connection is closed, then B send. How that is. Ankit Jaswal, I think I answered your question just 1 minute before. Push notification is the answer for your question, right? If B and chat server do not have an active connection, then messaging service has to pursue the push notification route. Which database type are storing? We can discuss. So messaging service is storing these type of messages. What type of queries do you think messaging service will get? What sender sent which message? What receiver received message at what time? Okay, so we have a columnar store, and we should support queries on a columnar store. So you can use a NoSQL DB like MongoDB here. Okay, you will not use the key value NoSQL. You will use a NoSQL, which is columnar. Okay, so MongoDB is a good example for this. What would you use for present service? Because it is just storing a mapping between A to CS1. What type of store will you use here? You will again use a NoSQL, but this will be a key value store. Okay. This will be a key value store, NoSQL database. So all our databases are NoSQL. Okay, highly scalable. How many active connection can chat? Frequently, this question is, I can't say that. That depends on the configuration of the chat server, right? If it is having 60 GB, then 600 connections. 1 GB, then 100 connections. Okay. Any more questions? Now, all the questions on chat are covered. Any more questions that you guys have? Is there anything else left?
One question I have now, all the messages are there. So now all these messages as a where is the linking that happens?
Link.
Like in the chat history, like when we open, we have all the messages in the chat history, right? So that one is that group ID for the group chatting. The other one, one-to-one chatting, how it will be
your
sender and receiver.
Yeah, that is firstly, there are 2-3 ways in which you do it. Firstly, your WhatsApp client itself stores that. Okay. So with your WhatsApp, whatever you're chatting, whatever you're receiving is stored in your WhatsApp front-end app itself. Okay. So next time you open, that is stored. If you scroll back a lot, okay, try doing this today. Then it will show loading and it will fetch from the WhatsApp server. Then where does it fetch the message from? Any idea? This table. Messaging service table. Okay. I hope that answers your question.
Why this wide column you mentioned? The reason for this?
No, wide column I didn't mention. I said MongoDB NoSQL is there, which is so see, SQL databases, most people think key value. It is not that. Even columnar data can be queried on NoSQL. MongoDB is a very good example for that. That's why I said key value store. We have already discussed DynamoDB or for that matter Cosmos DB are key value stores. Here you will use a columnar NoSQL database like MongoDB. Okay. Here you can query like sender equal to A, receiver equal to B, created time greater than XYZ, all messages. You will need all of these for the question that you asked to me right now, right? You'll have to do those type of queries. That's why you have a MongoDB. If you store it in a key value, then you can't do any of these type of queries can be done.
Only key is the query.
Correct. Absolutely. Great, everyone. Thank you.
Hi, sir. I have a last question.
Yes.
So when user is offline, then from the presence server, the entry is deleted, right?
Entry is not. Yeah, entry can be deleted, or it can be said that last active. Yes, let's say entry is deleted. Okay. It will be a log entry.
Okay,
to
thank
answer
you.
your proper question. It will be a log. It will be an event-based entry. Be connected to CS1 till this time, CS2 till this time, and right now it is connected to CS3, or it will be right now it is not connected to anything. Something like this will be there. We won't wipe off all the history of connections. Okay. Next question. What did you have? Any other question you had? You were saying something.
Can we get the recording session?
Okay, so for that, you will get the recordings on the link, which is our self-paced course. There you will get it. Like, we do not share it. You will have to get it via some of our courses. Okay. So some lectures are uploaded in our self-paced courses, not all. So this is part of our live batch. So our management team decides which lectures go in our self-paced, but you can explore our self-paced course. It will have quite a lot of material, but most likely you won't find the recording. We won't share recording to over email or something. You'll have to enroll in our courses for that. Okay, any other question? Okay, great. So let me stop the screen share. So that's all for today. Okay, so this was a good session, I think, on chat design of a real-time chatting system. So now this design is not just for WhatsApp. This also is valid for any type of chatting app that you use, like Facebook Messenger or whatever, right? So these fundamental concepts will always help you, especially the WebSocket part and the WebSocket to chat server discovery part, on-demand WebSocket creation. So these fundamental concepts should remain with you. Now there are some app-specific concepts like read, notified, sent, and whatnot. So these may keep changing, but the fundamental thing of WebSockets etc. will remain constant for any chatting system. Okay, so that's all which I had for today. I think with yesterday's lecture and today's lecture, now you can understand how notification service can be used as a component will be used as a component in any system design that we do. So I think this was the first proper good system design problem that we did, which used multiple components. In this, you can also fit a rate limiter somewhere. You can also fit a notification service somewhere. So this is the point which I wanted to convey, that if you know basic design, then you can accumulate a lot of, you will basically figure out that it is summation of some solved problem. A new problem will be union of a few smaller solved problems, and then it will be easier for you. So for example, tomorrow, if somebody asks you to design Facebook Messenger, then it will be union of WhatsApp design plus notification service design plus some other design. So you can combine an answer and present your answer properly. That will come with practice, presenting everything in 1 hour. So this is the summary of today's class. Any final questions? Anybody is having? Great. So thank you everyone. Thank you everyone for joining and for patiently listening to whatever we had today in the agenda. Hope this was helpful and hope you guys are able to understand how chat systems really work. So that was the main purpose of today's class. Thank you everyone for joining. Have a good day. Bye.
Recording stop.